Hey everyone, welcome back to Not So Sirius. My name is Tommy, and as always, I'm joined with Sam, Joe, and Michael. In today's episode, we decided we wanted to talk about interstellar space travel and the different options that the human species has to travel to other planets and other solar systems. As always, make sure to leave any video ideas you want to see in the future in the YouTube comments down below. We hope you enjoyed today's video. Catch you later.
To kick this off, let's talk about generational ships, which I think are one of the coolest concepts about interstellar travel. So the idea of a generational ship is that it's a ship that would take more than the occupant's lifetime to get to where it's going. And to do that, it would require the occupants to have children and then raise the children such that the children can then run the ship and so on for one or more generations until it gets to where it's going.
Except that there's going to be more than just 2 generations or 3 generations. It's going to be hundreds and hundreds of generations, at least with current technology.
Yeah,
the speeds we can reach to get to the nearest star system.
And then that does beg the question: will all of the intermediate generations have no purpose to their life?
That's true. What if the parents that went out originally, they had that explorative and curiosity when they went out, but what if their children or grandchildren don't want to be explorers anymore?
Yeah, it's very hard to call quits, especially.
Okay, look. If they're raised in an isolated environment, they're not going to know anything else besides exploratory.
I mean, besides even that, there's the idea of cryo chambers, If we can get that technology up to date, don't you?
Yeah, it's like the hibernation techniques.
Yeah, you just put people to sleep for a while and let them travel.
For a long while.
That way you don't deal with, having generations that question, why am I on the ship? Well, I didn't want to be here. You forced me to be here, that kind of thing. Granted, it'd be pretty cool to say I was born in space. That is
yeah,
true.
But I mean then you have this problem where you leave people. I don't know. It'd be leaving people for thousands and thousands of years potentially, which considering that the Egyptians were building pyramids only a couple thousand years ago, and seeing how far we've come now and how long that is, I really question whether a ship could be able to go for that long without encountering something disastrous in the meantime, and without having an awake human presence to be able to monitor it. If the ship gets hit by an asteroid and it gets damaged or something like that, or if it hits some kind of dust or something like that, then you would need humans awake to fix it.
So if we're talking about an interstellar voyage going to the nearest star system being the Alpha Centauri system, about 4.5 light years away, imagine if along the way something hits Earth goes extinct, or all of a sudden Earth or the people of Earth choose not to fund space exploration. Then what do you do if you're stuck in this generational ship going off to the nearest star system?
Yeah, it would have to be completely independent from Earth.
I feel like if you're going on a generational, if Earth is deciding to send a generational ship, then I think everyone has to be in consensus that it has to be supported. You can't just send something off like that and say, all right, well, bye-bye. We don't care about you.
Right.
That is the idea, that they would create something like that without precautions in place, and the idea that everybody who is on board to embrace the circumstances of their mission. You don't send it out unless everybody is on the same page.
And for the sake of the gene pool and for the sake of people's mental health, you're probably going to send 5,000 people on the ship.
Presumably, but there is this other thing where even when they get to where they were supposed to go, they would then be a completely different strand and completely different strain of human beings than the ones elsewhere. Because if it does indeed take them thousands of years to get to where they're going, in that time we went from whatever cavemen spoke to all of the thousands of languages that we have now, and culture and things like that evolved drastically. Yeah. So it would mean that you would have this strain of human beings that might be acting and thinking and talking and culturing differently than all of the other human beings elsewhere in the galaxy. And then you get to this philosophical question of, are you really spreading humanity in different places if humanity can't be connected?
That's a very good point. And so, for example, the fastest manned spacecraft was Apollo 10 reentry, and that was going about around 40,000 kilometers per hour. But the fastest spacecraft to date is the, I think, Helios 2 mission, which reached around 240,000 kilometers per hour going in its orbit around the sun. And so if we went at that speed, around 240,000 kilometers per hour, for this generational ship, say that's our best technology or highest speeds we can reach with current human technology, that would mean it's about a 20,000 year trip to the nearest star system at 4.5 light years away. And that would be around 600 generations. And so when you compare us humans right now from 600 generations ago, I mean, there's obviously huge differences between what they are and what we are right now.
Yeah. And a generational ship like that, I mean, it would take a planetary effort to get a project like that underway. And then you would wonder whether the efforts would be met with reward, because the reward would only come, it would never come for the people who stayed on Earth, potentially. And I mean, or it would require very species oriented thinking. And so that would mean that you would have all of these people who would have produced this massive effort to get a generational ship underway, and then who would never get to see the benefits of it. And then presumably it would be, a generational ship would have high uncertainty of getting to where it's going. So that would mean, I mean, that might not be a feasible thing perhaps humanity's efforts should not be focused on building a generational ship. We should be focused on finding more efficient ways of getting to other places.
Yeah, I agree with that. We should definitely focus on getting faster and faster with our technology, because of also something called I think it's called the weight calculation, where if we sound out a ship right now with our current technology to go to the nearest star system, say in 10, 20 years, since technology tends to advance quite quickly, a new ship will be formed, or new technology will be created that can go, twice as fast, 10 times as fast. So eventually that new ship will pass the old ship. And so you have to get to the point where we can't really go any faster on technology. So that's definitely something we should focus on instead of sending out thousands of people on a generational ship.
Yeah, but there is an idea of sending one out first, just to
kind of pave the ways.
To get a better grasp of the situation and the conditions and like what it's like with experiences. So that, like, I think if we're gonna send out a final like hurrah with the best technology ever, like you have to have an understanding of how to be the most prepared.
Yeah.
Like I mean, there is I feel like a sentiment to like I don't think it's bad to send out a ship first, even if technology isn't at its peak, because there's an idea of experience. Like, well, this is terrible because it sounds like we're experimenting humans, but like there's an idea of like that first step of like seeing how things go, seeing what things are like. Like there has to be. You can't just send your final project out like that.
There is also though some kind of ethical consideration, because I mean it's taken totalitarian regimes. I mean, it's taken totalitarian regimes to tell people what to think and to make people think what we want them to think, which would be required on a generational ship. And as we know, human beings are not meant to live like that. So it could potentially be altering the future of humanity in a way that's in a way that's unacceptable to humanity, and thus kind of nullifying the point of sending a ship like that, because the idea would presumably be that we would be continuing humanity, and this could be just an end to humanity. So in some sense, there would be no point as well.
Yeah, I mean, I think if you're sending someone out to space, I feel like you have to embrace the fact that humanity is going to change.
Yeah,
like there is no getting around the fact that we're going to change. We're going to have to change fundamentally as people. You're going to have to adapt to the new environment, especially being on a ship for that long. And then even after that, like when you get to the system, like we haven't even discussed the possibility of like, do we even know if there's a habitable planet or something that we can even land on, like out there? there has to be that level of security as well, where you're able to do that. But like we're so far away from that as well. Like there's a lot that goes into
And
this.
even if there isn't a planet, how many trips and how long is it going to take to terraform and dig underground and supply oxygen enough to even have an infrastructure for people
And
to stay?
you also have to slow down. So if it takes 20,000 years with our current technology to get to the nearest star or planet around that star, you also have to it'd be around 40,000 years to speed up then slow down to actually arrive at the planet.
Yeah, and then even when you get there, what does life look like? Because if it just means that it's just more humans who are able to do exactly the same as they can do. The ideal objective would be to land a planet that's Earth-like and can breathe the air.
Not only that, we'd be like cavemen and cavewomen. It'd be going back in time, essentially.
But
presumably it'd be like going back in time, assuming there's nothing out there already. But like, think about it.
But also, if it takes you 20,000 years plus to get there, then all of a sudden humanity is going to have evolved 20,000 years on planet Earth in the time that you missed. And so you have to kind of catch up, or you have to also, you're 4.5 light years away, meaning that when you communicate with Earth, it takes 4.5 years to to find out what happens.
Cool thing would be a cool idea that I just had would be if you could just send raw building materials with the spaceship, then the people on Earth who are still doing research and things like that could once they've discovered something, a viable new or an interesting new technology, they could then give instructions to all the people on the spaceship on how to build it again. On how to replicate what's going on Earth.
There are a lot of nuances to this.
Yeah, I think there's 3 facets that we have to focus on. One of them is the diplomatic. One of them is like the very scientific, like how are we going to siphon this much energy to get there and build the infrastructure? And then the other one is biological, like how are we even going to be able to survive, open space that long with the amount of radiation and stuff?
Yeah, yep. And for sure, it's not going to be humans that reach the nearest star system first. It'll be like some kind of probe.
It has to be. You can't move that fast without like.
You can't send out people not knowing that there's a habitable world.
Basic physics, right? If you want to travel the speed of light, you can't have mass. Particle can have mass, right? So like, if we want to get close to that speed, it has to be something so light where it's not being held back.
And I think ideally, at least for the nearest star system, since it is 4.5 light years away, you'd want to go or approach about 10% the speed of light. So get there in about 45 years.
Yeah, that would be kind of the minimum, the maximum viable time for there to be a point for human beings to embark on such an endeavor. And then, then there's loads of really cool means of propulsions or theories about means of propulsions that could get us there that fast. There's those antimatter engines. There's warp drives, which we can talk about a little later. There's all of those other technologies, which just exploring those would give humans on Earth probably.
Oh, right. If you can feel a generational shift, then you can feel planet Earth, or the amount of energy you can have like on Earth itself to supply things would be insane.
Right.
I might have the fact wrong, but I think if we utilize 1% of the sun's total energy, it'll be like 72 billion times the amount of energy we use, or something crazy along those lines.
Maybe then humanity should focus on building a kind of Dyson sphere around the sun, and that first, and then once we have this unlimited energy, then we can embark on interstellar.
In my opinion, that's kind of the most feasible way, is to propel ourselves so far forward that we have all the knowledge and technology to create the best drives instead of creating them as we go. Because eventually we're going to need more energy to create the more expensive and better drives that propel ships.
Yeah. Well, but the concept of a warp, to send so the idea of a warp drive is that it would, I believe it would create some kind of space-time pressure differential on either sides of a spaceship, so it would just be flung through space really, really fast. but the
Like a
energy
wormhole.
that would be required to create that kind
Right.
of space
Is
time, to warp space
It's
time
like
in such a
planetary
way,
size. Yeah, at least.
it's so much energy that I think I mean, if humans, it might just not be possible for humans on Earth with our sun to do that.
It might not even be necessary to send someone out to space if you have that much energy at hand.
Yeah,
Right.
because
Like you could do a lot with that much
We
energy
could
on
build
Earth.
our own planets with that much energy, you know?
Like
yeah,
A good point.
think about it like just logically, I don't know if warp drive will ever be possible. Like the way they depict it in movies and stuff, it looks so easy.
Well,
it really does look so
Think of
easy.
like a human trying to break through space time to move that fast. Like that, I don't think you would feel okay after that at all. I
Yeah.
don't think it's as simple as, oh, I need to throw up now because I did that. Like in Star Wars, right? Like
if Hollywood did it, we can do it too.
like you could probably die if you travel that speed. It's very likely you're gonna die.
The other thing is that as we know, the whole special relativity time dilation thing, if we do travel really that fast, then what happens to the people back on Earth? They're going to be thousands of
Age
generations
older.
are going to pass,
Yep.
Right.
and then you're just this prehistoric remnant of a human being,
Yep.
just out there.
But the faster you can go, the better. Not only because you'll arrive there faster, but because you'll experience less time. So you don't have to worry
but then
about.
people on Earth will if you can really go super fast, a significant fraction of the speed of light, then the people on Earth are going to slow down. But on the other hand, the time dilation only works by a low factor of not even a factor of a couple until we reach 0.6, 0.7 of the speed of light.
Mm-hmm.
So, and if we're able to go that fast, then we have a lot of options in terms of going to different places in our local area of the solar.
Yeah.
Of
I think
the
historically speaking,
galaxy.
one of the first notions of, other than from science fiction, and actual U.S. funding of interstellar space travel would be. You mentioned earlier the Dyson sphere, but Freeman Dyson also had the idea of what's called the Orion project. I
Yeah,
believe.
the Orion
So that was
project.
basically just to drop a bunch of nukes off the back of a spacecraft and see how much speed you could pick up that way.
Which would presumably be and it would be good to get some numbers on that. But
I saw something online, and you'd have to first you'd have to go against all international treaties about increasing the amount of arms or nuclear.
Yes.
Right. Well, if you launch a nuke,
nukes.
in the upper atmosphere, you're spreading radiation across the entire planet.
But if you could somehow get the nuke if you could park the nuke in space well clear of the Earth before you set it off, then that could presumably be fine. Because I mean, if we set off a nuke close to the moon, it doesn't really matter for human beings on Earth, and no one's going to notice.
I'm really trying to imagine that right now. I'm just thinking of like little carriers that
You
are
just
holding
make like a
nukes.
big dish and then you
Holding
blow a
nukes
nuke up in the
and
back.
They're like going up. They're being launched. But just imagine that though. If you're trying to send nukes up into space, what if a launch goes wrong and it crashes?
Yeah, that's a
game
problem.
over. Like that's
True.
game over.
Yeah, but you
Game
could
over.
imagine a future society where you don't launch the rockets from Earth. You launch them from the moon. You launch them from Mars. You develop and build the nukes on different.
I feel like if
planets.
we're able to get onto Mars, we're able to get onto the moon. I don't think we have to use nukes.
And
further in space. I don't think that would be the end all be all solution.
To be fair, we have had some problems with nukes. I mean, a nuke.
There's a plane that
US
dropped two of them
plane.
over North Carolina.
Yeah, and a
like
nuke
one of them hit the Earth and just got lucky.
Yeah, and this nuke fell out of a plane over Spain, and it leaked plutonium everywhere.
Oh my gosh!
Over entire square kilometers, and we just sent some people in some gear to go hoover it off the ground, and it was fine. So vacuum or whatever off the ground. So I guess that, and the other interesting consequence of using nukes is that you would need presumably a huge spacecraft made of really, really solid materials to be able to not break up under the impact of a nuke next to it, which would then mean that we would be traveling the cosmos in the utmost comfort, unlike all of the other space travel systems that we already have, which are scarce at best, which are uncomfortable and unpleasant and really small and cramped.
I think we can all agree that no matter what the technology is, we can't use our current technology, which would be chemical rockets or liquid fuel to go interstellar.
I also,
Right.
yeah, I don't know. I think if we're able to make that amount of energy, like, I'm just worried what other countries will want to do with that. If someone discovers that kind of prospect of like, oh, we can this fuel system that we can use, like, think of the weapons that people will want to make. Think of like the aircrafts and stuff like that. The one it's gonna be. I think
and that's the diplomatic issue. Like,
there's a lot.
It'll either need to be like internal top secret, which I don't think will work,
Area 51.
or an entire global effort.
Also,
the other thing is like is that if I think about computation power, if someone told if someone from today told someone in the 60s how much computer power we would have in the 21st century, they would be thinking who could possibly need that much computation power, and it'll only be for people to send ciphers and for people to do horrible things online and remotely. But then nowadays we use computation power to play Angry Birds on our phone.
Yeah, but there's also a level of like, as you scale higher and higher, the danger will go higher and higher more.
Mhm.
Like, you think about it like that. The more you progress, the more risk and the more like, that I don't think it would. I don't know. I guess it might in terms of like the current technology in the future, like it might seem balanced, but compared to now and compared to like just in general, I think it'll be much more dangerous. So,
and also, it might have been what I just said might have been a dumb thing because the internet does do horrible things to so many people. So that might have been a dumb thing.
Well,
and also
we could talk about this in a future episode, but like as technology and like computing power gets higher, people are going to be more inclined to make robots. But is that necessarily like a good thing?
Yeah. Also, in terms of nukes, maybe the best idea is not as the Orion project thought, drop nukes off the back of the ship, but maybe it's to harness nuclear fusion to have all that energy,
right?
Instead of just
accelerators on ships.
Yeah, and I mean, if we can, I mean, there are already designs there are already propulsion systems that use mostly electric power to accelerate their own fuel.
Right.
So if we could, for example, have practical fusion on a spaceship, then we would be able to develop a system that could harness that energy efficiently and make it propel.
Like, and then even more efficient to that would be the idea of anti-particles annihilation.
Yeah,
that'd be the most efficient way.
But I mean, at the moment, we
only have like 6 grams and it costs like trillions. Yeah,
it costs trillions of dollars per gram.
Fun fact: it would take 10 grams of antimatter to travel to Mars in 1 month.
That's it.
10 grams. Oh, that's a lot. 10 grams.
We're already halfway there, and it's only taken us 60 years.
Sounds like you're talking about drugs.
I mean, I'm sure you can find something that'll take you to Mars for a lot cheaper.
10 grams.
Going off that, what if there was your friendly neighborhood antimatter dealer, and if you could find him, then you could get to Mars really, really fast?
Get to Mars in a matter of a couple hours.
Anyway, so talking about the technology we currently have to go interstellar, I think the best candidate would be the solar sail. So basically putting a laser either on the surface of Earth, on the surface of the moon, pointing it at this giant, I don't know how large they would get, but imagine a square kilometer of this material and just having it running off this laser. Yeah,
but I mean, presumably the acceleration would be minute. Even though it would be perpetual, it would still be minute. And so you wouldn't get... you would presumably still take you thousands of years to get anywhere.
And then you have the problem of how you're going to slow down, because you still need fuel to slow down.
But with the current idea of the solar sail, I think you can reach feasibly 10% the speed of light. But as you said, Joe, just an issue of how fast it takes you.
Well, you also have the issue of, the Earth is going to be rotating around the sun. How are you going to, constantly keep the laser on it and not blow up some planet way off in the distance?
And then there is the the whole slowing down element,
Right.
which there is no laser where we're going, presumably. So if we can't, or I'm just thinking, could you just mount the laser on the spaceship itself?
That's what I thought. Because I don't know if you can use a circular particle accelerator like they have at CERN. Like, I think you'd have to do like Michigan State does. They have a linear one because then the warping won't affect your trajectories. But I feel like if you put a linear accelerator on your ship and then attach it to the laser just behind you, that might work.
Wait, and then what happens to the particles from the linear accelerator?
Oh, like if you're going
What
forward,
is that for?
they'll stretch out instead of like if you imagine a circle going very fast, it'll become an oval. So your particles might shoot out the side. But if you have a linear one, the accelerator will just stretch out.
Oh wait,
but
a laser is
still be
light.
straight.
It's not matter. It's not
Right, but
matter.
if you use the particle accelerator to make the energy for the laser internally.
Oh, well, presumably we could just have some kind of nuclear power.
Right.
That
Yeah,
would be the
like
most efficient
if
way.
you attach the laser to the ship with some kind of energy device.
Yeah, the only thing that I'm wondering is, so at least my understanding of the solar sail is that every time a photon hits the solar sail, it imparts a little bit of momentum to the ship. But do you get recoil off a laser, basically? That's a question that I have
Right.
I'm not sure. So you could be trying to push forwards, but going backwards.
Yeah,
It's not getting anywhere.
exactly.
It's kind of funny. You go back
Well, then
and forth.
you just turn around. Yeah. No, you just aim backwards and then you try to shoot forwards and you just keep going backwards.
Anyway, so solar panel, definitely a good candidate.
Yeah.
In terms of the near future, that's about it.
But
It's just so far in the future, like I don't.
We're talking
I don't
probably at least 1,000 years until we're somewhat in the realm of possibility.
I don't know, because all of these technologies, even warp drive, they sound so far away. But given what we can do now, and
Right.
compare that to what we could do 100 years ago,
That's
it's
true.
not even close. So
Well, in
it might
5
only
years,
take us
we're
a
gonna
couple more years.
utilize the moon.
I mean, there's
Right.
also like the idea of scale, though. Like, I think I brought
Right.
this up in the past. But as you increase, I don't think the increase in we're advancing gets higher and higher. Like, granted, we might not know because we don't know the full extent of where technology can take us, and so we don't know what like the full development curve is going to look like. But right now, we've already figured out so much.
The other thing
we're
that
still learning, but
the other thing that we can think about is that we don't know the physics that we don't know. So Newton, calculated how things moved, and then as we learned in class, by the late 19th century, physicists thought that physics was solved completely, in that
very true.
we could explain most of our earthly phenomenons. And then someone found motivations to develop quantum theory, and then Einstein just brain made relativity. And then now we have a fundamentally different way of viewing the universe, and we still can't reconcile relativity with quantum theory, which could mean, I suppose, that there is another even more fundamental understanding of the world that exists that we just that we can't understand yet. And maybe in only 50 years of more physics, we'll find this alternative way of thinking about the physics of the world, and that could open us onto
but the thing is, like, even if you discover all this physics, then you still have the engineering problem where like you need a lot of energy and a lot of time to actually utilize it.
I feel like it'd have to be engineering first before at this point. So I don't think we can analyze the particle. Like, I think quantum is all on an atomic level, right? We're going to need a certain level of technology that can allow us to feasibly and like regularly look into how particles are moving, so we don't have to theorize anymore. Because a lot of like we can confirm a lot of things, I feel like, through certain technologies that can allow us to see deeper. Because we have a very surface level, I feel like, understanding of quantum physics right now. And with our current technology, we aren't able to go any deeper than that, and we can only theorize and expect certain things from certain experience.
Yeah, I mean, I guess who knows what the future in terms of physics
That is
holds for
very
us.
true.
But I mean, even when you watch a movie like Interstellar, for example, the ideas that are advanced in that movie of going through a wormhole were even though they're mostly science fiction nowadays, they are still motivated by some kind of physics that we know.
Like they had for that movie, they had Kip Thorne from Caltech be the science advisor to make sure that the science was, for the most part, correct.
Yeah.
Right.
It was
And
well made.
the black hole scene, they worked with actual scientists and it won like a couple scientific awards because of how accurate the model of the black hole they made was.
I mean, and then there we come back to this thing that we talked about last week on human spaceflight, where should humanity undertake these massive efforts to get somewhere that really might not be so different than Earth?
Yeah.
Because I think on one hand, humans are fundamentally explorers and they want to go find new things and they want to see new things. But what if going to another place in the solar system is just mostly the same as Earth with a little twist? What if it's Earth but with different colors and slightly different gravity? It is, and rings around the planet. It's still not so different.
Yes, but there's also some comfort in knowing that we are a 2-planet plus species, not just reliant on one planet.
Think of overpopulation and that kind of issue, and resources that we have on Earth right now. If we want to sustain life, there's a lot we can do with.
Yeah, we can start small. We don't need to go international.
Granted,
like if we can
go for it. Sorry.
No, if we can utilize fully the surface area of the moon and then use 0.1% of the amount of asteroids as materials, that'll propel us so much further in civilization than like people would think. Like we can start small scale because that propulsion can then lead to discoveries that help us look further to Mars and Alpha Centauri.
Yeah.
And to look on a more earthly scale, humans don't really remove things from the Earth. The Earth is mostly a closed system. So whatever we take out of Earth, we also give back to Earth in some way, even though oftentimes nowadays we don't give it back to Earth in the right way. The materials on Earth are in some regard infinite. There is some amount of carbon on Earth. There is some amount of every other element that every time we use it doesn't change. It still exists. It's still on Earth. So if humans can focus on developing just science and technology here, we might completely need to remove. We might have so much progress here that. And that we might have so much progress here that we would nullify the need to go somewhere else. And the other thing that I was thinking is human civilization today is leaps and bounds different to what it was 1,000 or 2,000 or 10,000 years ago. In some sense, we are a different species. We're different culturally. We're probably a little different. And nothing is the same. So in some regard, just staying on Earth is kind of like interstellar travel. It's going to be different. Nothing's going to be the same. So that might also remove our interest in going somewhere else.
Right. And that's something we could talk about maybe next week, like in terms of what it looks like on the Kardashev scale, like the evolution of civilizations and like the possibility of the Great Filter, like a point where most life can't get by, whether or not we're approaching it, whether or not we're past it. And I think it's a lot of interesting topics that we can hit on in regards of what we could do specifically on Earth, and then what impact even solar system travel can make on that.
And I mean, we still have billions of years until our solar system is compromised,
right?
And that it cannot sustain life in any way, because the sun is going to start to die and it's going to expand and engulf all of our planets here, and then it's going to explode.
Mm-hmm.
But we're still billions of years away from that.
So far away from that.
Which is so far away. So I think if humans can focus on not destroying themselves in the next couple billion years, by that point, we will probably have understood something so fundamental about our, well, I mean, life will be so different that it's kind of like we've just left our planet and never come back. If to us, at least, it's
right.
There is an onus
It'll
on
just be a stepping
sustaining
stone
Earth
at that point.
itself and focusing on that as a more pressing matter.
Right.
I think the technology will advance on its own as long as we give it time and as long as we give it the resources and the necessary.
I also don't think that interstellar travel is going to be motivated by this attitude of exploration. It's going to be motivated by, as you said, Joe, either a need to leave right away,
necessity,
a way to save our species, or perhaps even for
we don't need humans don't need to. I mean, I don't know what the economies of the future are going to look like, but if we just assume that humans are going to be greedy at their core, like they've always been, then it might be. I mean, if we can already mine asteroids, that's already going to be a huge.
Right.
Huge,
that'll open our system to so much more material than we have.
Then, I mean, maybe one day mining asteroids is going to be too easy and we're going to run out, and then we'll need to send human beings somewhere else. But this comes back to the debate that we had the other week of, should we be focusing on sending probes far away or human beings far away? And I think of the three motivations of the three motivations to send human beings away, economics is the one that makes the least sense.
Yeah.
Then, I mean, a pressing need to leave the Earth because we've messed it up too much. There's an
asteroid or something.
That I think is the most likely reason for humans to be properly motivated to leave the Earth. And by the time that comes around, either, I mean, we might just be content with going to Mars or to the moon, and that might be enough for us. Because we're still billions of years away. We're very far away from the time that even going to other places within our own solar system become insufficient.
There is a necessary need. I mean, there's a lot that has to be developed here.
Yeah,
right.
It's what we choose to focus on, and
like interstellar travel isn't solely a scientific thing.
No,
I mean it's going to be a lot of politics, a lot of diplomatics, a lot of biology and engineering.
Who to even send, right? There's the issue of that as well. Like, who do you choose to send? What qualifies a person that's able to get on that ship?
Right. And the other thing is, will people want to be on? Will people actively be seeking to be on that ship that leaves the Earth, or will people be doing their best not to be on that ship that leaves Earth? That's going to be.
I mean, given law of averages, I'm sure there's people that are going to be willing to, do all the training.
Or not, because if it is that you're going on the first
suicide mission,
it might just be a suicide mission with very little returns. And even though life on Earth might be, but I don't know, some people might, life on Earth is very, very tough for some people. So there might be a very good incentive on being elsewhere.
Right.
But there might not be that.
Look how big media got just because of the escapism of the problems on Earth.
Yeah. And then, by the time, it might be that by the time that human beings really need to leave Earth, going to Mars is just like taking the plane for us and going to a different continent. And by that point, they might not see going to Mars as, long distance travel. And at that time, it might be that humanity, which is a two planet species, is looking to go to a whole different galaxy at that point. And then that might be their new standard for interstellar travel.
Yeah.
Although I should say that interstellar travel is not intergalactic travel.
Intergalactic travel is pretty much impossible with current physics.
Yeah. Unless you can somehow warp space-time.
Right.
Which
could be soon. Who knows?
And it might be really soon.
Yeah.
Nuclear power was not even conceivable until the 19th century and 1940 some, and in the early 40s we were able to do it. So we might be very
No,
close
but
to
this
it.
is nuclear power versus intergalactic travel. You realize the distance of scales you're looking at right now, right?
The
But to
nearest
be fair,
galaxy, 2.4 million light years away.
at the end of the 19th century, we didn't even understand much beyond. We barely understood much beyond the atom. I mean, quantum theory was non-existent.
Yeah.
So we couldn't even. It wasn't even conceivable that we could break the atom at that time.
Right.
And we can already right now conceive of intergalactic travel. So maybe it's possible, but it should be. Also,
I don't think it's
also worth
focus
noting,
we have
though.
to should look at though, right, as of now.
Also, one issue I'm thinking about in terms of, Joe, you mentioned the idea of some people like choosing to go interstellar or choosing to travel these different planetary systems. But imagine a future if they go on a generational ship where it's 600, 700, almost 1,000 generations later, where they kind of forget where they come from. And so all of a sudden they see themselves as their own species and they see us as a different species. Or even if they're like intergalactic wars, where some humans forget that they came from originally planet Earth, and all of a sudden they're waging war on us.
I mean, before we start waging intergalactic wars, I mean, that's, millions of years after that.
They're in a ship and they're fighting.
Yeah. No, but I don't know. I feel like even 600 to 1,000 generations later, if they see themselves as a different species, is that so much of a bad thing as long as it stems from humans now and it's preserving?
I think they will hit a certain utopia at a certain point if they're on a ship together.
It comes down to this fundamental thing of what does it mean, to be part of a species, because the whole point of being every other species is to reproduce and the continuation of the genes, kind of regardless of your own life, or regardless of your own life. But for human beings, I mean, at least in the 21st century, we've reached this stage where that's not really true anymore. I think, at least for me, and I think for most other people, it's hard to conceive of just not caring about me for the sake of I don't feel a drive for my species, and I think very few other people feel a drive for their species. So they, if it took a massive effort that would, to get people going away, what would be the point of that? If because they would likely not identify as the same as everyone else back on Earth.
And then people back on Earth can make the argument like, oh, they're going, so we're just left behind.
Yeah. And then, I mean, I know we've been talking about
that's a lot of ethics going on,
Yeah. And then, I mean, what about basic human psychology? What about infighting on the ship, power struggles, all of these things, which are very real part of human life?
I'm just saying, at one point, those generations are going to hit a point where they're going to see themselves as the same people. And so I think all that power struggle it might happen, but it won't be on the scale of, oh, I hate you because you're this kind of person. I'm sure like they're going to see themselves as one people at that point. And so like, I think that phases out some of the things. We might have to go backwards to go forwards, honestly, on these ships. Like as people, we might have to like undevelop in a sense, because like we might have to go back to basic human roots in order to move forward, like with these ships, I think.
Yeah. And then, I mean, the whole, how do people live on these ships? Do they go to school? Do they learn how to read? Do they garden? Do they have like an outdoor area, or are they just kind of strapped to their seat and going to the bathroom and that's it? Because the size and the magnitude of these ships would, I mean, that we have no standard for what a generational ship looks like. It could be huge and have individual rooms and all of those things, which would also make a difference.
A few ideas I've seen in terms of what a generational ship would look like. One would be hollowing out an asteroid. So say you already know an asteroid's on a certain trajectory, or a comet, something that's going to pass out of our solar system. You could hollow that out, somehow capture it, put people inside, and just use that. Another idea, which was in the end of the movie Interstellar, and also it's been brought up by Jeff Bezos, head of Blue Origin, in one of his recent talks where he wants to build those giant cylindrical structures that basically
I
spin.
think that
forget
one's
what
the
they're
most
called.
feasible.
So basically,
But
try to
you just
simulate Earth
rotate
as
them.
much as possible. Yeah, try
Right.
to simulate obviously Earth's gravity, but the environment of Earth, so that generation over generation, people, they still feel as though they're living on Earth. And
Yeah, and Earth is
That one
kind
would be
of
better for like food generation as well.
yeah, and I mean Earth is kind of its own it is its own spaceship. We are kind of all flying together on Earth, and so another ship that is Earth like might be perfectly content to just be flying with no goal. Because
that's a very good point.
right now we're all traveling through space with no end goal, and we're just going, and we get on with our lives like everyone else does.
But there's a sun, though. We have a sun. You're ignoring the fact that we wouldn't have a sun.
But
if
you
we're
could
going to be
have some other source of energy. That could
perhaps, yeah.
Right.
But
Yeah, I mean, I don't love my son. I think it's the sun, but I have no particular feelings towards the sun. So
it's a necessity, though. You're missing the fact that it's a necessity.
It's a
Right.
necessity. But I think if we didn't have one and we could still be fine, I wouldn't miss it that much.
I think
Right.
that's a great point, Joe, where instead of going out to a certain already formed rocky object that we call a habitable planet with water, or instead of building our own planet, instead of just building a structure that replicates what a planet would be, where humans can still live, there can be cities. And
That would have to be massive, though.
But given the technological kind of entry point, that's the technology that's needed to achieve interstellar travel, at that point we'll likely be able to put huge structures into space and make them travel.
Mm-hmm.
So if you could have a giant spaceship with a school and mountains and lakes and rivers and things like that to be in, I think I would be perfectly happy living on it. I don't think it would be that different from Earth.
At that point, it'd
In
just
fact,
be an artificial
for most
planet.
people,
I feel like we're talking about a book right here.
Yeah, like it would be so massive it'd have its own gravity and stuff.
yeah. But I mean, for thousands of years, a human existence has been confined to your own village, nothing else. For thousands of years, we had no idea, the shape of the Earth or what it looked like or how big it was and what was, beyond walking distance from your village. And people were perfectly satisfied with that.
But what happens when you reach the edge, huh? Is it a flat? Is it a flat ship?
it's a circle you walk.
Is it a flat ship at that point then? So what is it? So we're talking about here.
I mean, what it would be. This is, I know, probably highly unethical. But what if we put babies on a massive spaceship?
Oh, that's introduced in the movie Interstellar. That's the whole premise, where they go on the ship and they originally send out a few astronauts to explore what's beyond the black hole, those however many habitable planets, see which one's habitable, and then they already have seedlings to put on those planets.
Yeah, but then so I mean, if let's say we put babies on this huge spaceship that was going, and the babies had food and things like that so they could grow up, they would then rediscover everything that humanity has discovered about its own planet on their own spaceship.
It'd be like cavemen.
So they would wonder, what's beyond the edge, and they would go to the edge and they would say, oh my God, there is an edge. And then they would discover the shape of their thing, and they would discover physics and all of that.
But you could also ask the same question: what if that was done to planet Earth?
Yeah,
See,
but then
it feels like this is where conspiracy theories come from.
Yes, but
we're all living in a simulation where there's a hologram and the government is controlling everything.
it is an interesting thought. What if we were on a spaceship that other really sadistic human beings? What if other really sadistic human beings found Earth and were like, this is the right place to dump some babies? And then
there are different theories to debunk that, but
I mean that'd be interesting, and that's
a topic for another day.
Yeah, that's something we could hit next week.
I think you go into a kind of a rabbit hole of just continuously thinking of other possibilities when you go down that thought line, and it's not very realistic in my opinion.
I mean, it's not very realistic, but it is cool. It's like all of those. It is interesting to think about, and it does make you question the basis that we have to evaluate our own world. We think that the world is like this, and human beings are pretty confident that they know that their world is such and operates as such. But we can't. I mean, we can question some of those beliefs, and I mean we should.
We can try, but I don't think it's very healthy for your mind to continue to just be paranoid about everything where you see
Right.
something like that's a sign from the government that they're controlling us right now. That's where you get these kinds of people, like,
Well,
Thanks, Sam.
Okay,
I don't
okay,
think it's
but
healthy to go
in
down-
terms of interstellar travel, that's something that we would have to figure out psychologically
perhaps. Yeah.
before we start.
Hmm.
You might just have to tell these people you're on a ship. It might seem like it's Earth, but you're on a ship.
Right.
And then just leave it at that,
Yeah, well,
So-
we'll give you quantum computers with all the knowledge that we've found,
yeah, and you
but
know
you're on
how
a ship.
Feynman was, I don't know if he was presented or he came up with a thought experiment. If you could leave if humanity was going to get wiped out, and you could leave one message to the next group of intelligent species or the next generation of people, Feynman wanted to write there are atoms, or atoms exist, or something like that. What if that experiment was run, and instead of it being there are atoms, it looks like you are on a ship.
But there's something similar to that. It was probably also for show for the public's interest, but on the Voyager spacecraft, they put the golden records.
Oh, right.
They put like what the humans look like, something that symbolizes in terms of a map of the sky where Earth would be, which I don't know how they did that because you don't know where it's
I
gonna
think it
end
was
up.
like in terms of like Orion or something, and then they put like an arrow like where our solar
And then
system would
they
be.
also said hello in I think almost every single language.
Yeah.
Or welcome or something like that.
But I mean, this whole idea of, going back to a more serious note, this whole idea of interstellar travel is so interesting, because it makes us, the notion of interstellar travel makes us question everything about who we are as a species. Because as a species, we've developed a certain notion of our world and all these truisms about the world. And thinking about a completely alternate path for our species, I think it's a great thing to be thinking about.
I think there's much to learn from people who explored the world before.
Yeah.
I think
Mhm.
if you can dive into the minds of the people who explored Earth when they first went out, it would be we can kind of get a sense of what it would be like to be on a ship.
Yeah. I mean,
And exploring space and pushing the frontier that way, I think, honestly, to me, that makes the most logical sense of how you would deal with that sentiment of, what am I, like, where am I going? What is this?
I mean, because I know that, all of the early explorers, Magellan, James Cook, all of those people, they wanted to map the world. And the things that now, but I assume there was still something deeper that drove them to want to map the world. And it would be really interesting to be able to tap. I mean, I assume there's already literature out there, and people would be thinking about what drives great explorers to go explore. But I think this is where interstellar travel might just be I think it's maybe interplanetary travel for us is what traveling to Antarctica was 100 years ago.
Mm-hmm.
And it's an awesome sight for humanity. It's an awesome prospect for humanity, because it lets us know that there are still things to be done. There are places to go. And I think it's great motivation for people who want to study sciences. It's great motivation for human beings to know that our mission on Earth is not finished. And I think it can fill us with optimism about our future.
Yeah.
Right.
Sure.